Hey guys, earlier I saw this statistic that said if you're in a room with 23 people, there's more than a 50% chance that any two people share a birthday. When I read that, I don't know, I didn't know what to think. I was like, there's no way that's true. That's so counterintuitive. I mean, if I was asked that and I was asked to reply in an instant, I would say that the probability, I would say for the probability to be 50%, there'd have to be whatever half of 365 people is. But I did some research, and that is not the case, and I'll explain why. So, I made a little program to do this, and it has a few variables that affect the outcome. Probability, the chance that it's not your birthday, and the number of people involved. So the probability is the final number we're looking for. We're asking if X people are in a room, what's the chance that any two, that's important, will have a common birthday? It turns out that this is easier to solve if you solve for the probability that it's not their birthday first. And this initial value is set to 1 for an important reason. I'll explain that. Here's some code, you can just ignore that. The initial number of people has to be 2 though, because you can't have people sharing a birthday unless you have 2 people. That's common sense. It goes all the way to 365. Now, in theory, it is possible to have a room with 365 people and everyone has a different birthday. By the way, we are assuming that leap day does not exist for this. So, the chances of that happening, of 365 people in a room at random with different birthdays, is extremely, extremely unlikely. So, the computer is going to go from 2 to 365. And what it's going to do is change the value of the chance that it's not your birthday and the probability. It'll then print out the results to make a nice little table for you guys. So, let's say I'm in a room, I'm the only one in a room. I could have been born on any day. There's 365 days in a year, and I could have been born on any day. So, 365 days out of 365 days is equal to 1. That's why this initial value is 1. Let's say you're in that room with me. The chance that the probability you were born on a different day would be, there's 364 days available. You can take any one of those days. So it's 364 over 365. We get a third person in there, and I have my day, you have your day, and our buddy Steve has 363 days to choose from. He can have any one of those. So to find the probability that we're all born on different days, we would have to do 365 over 365 for me. That's just 1, so we can negate that. You have 364 out of 365. And our buddy Steve has 363 out of 365. What we do with those numbers is we multiply them. And if we want to find the probability that we do share a birthday, then it's 1 minus that number. So what I'm telling the computer to do here is find the probability that it's not someone's birthday and multiply that by the previous value. So 366 is our initial value minus number of people. Number of people starts at 2, so it'll and not B day starts at 1. So what'll happen is the computer will go through this once. It's 1 times 366 minus 362, which is 364 out of 365. That's not birthday. So the probability of you and me, once again, is 1 minus that. The computer will store that value though and do 363 over 365 and multiply them together for the next time. And it'll keep on doing that till it reaches 365. And with this print command, what that ends up so here are all the people, and here's the percent chance that any two will share a birthday. Let's look at some key points here. So 2 people, you and me, the probability that we'll have the same birthday is 0.274. That is a little bit under 3 in 1,000. So think about it like this. If you looked at 1,000 married couples, only 2 to 3 you could expect to share a birthday. But let's say we're in a room with 15 people. If there were 4 rooms of 15 people, you could expect one of the rooms to have 2 people who shared a birthday. But let's say we got all of those people together. So we have 60 people in a room. There's a 99% chance that 2 of them share a birthday. So this is not a linear scale, clearly. Let's try and find the tipping point. 23. Like I said earlier, 23. 50.73%. 23 people in a room together, there's more than likely 2 people have the same birthday. You get 32 people in a room, which is 9 more, there's a 75% chance. Now, this number approaches 100 and it eventually hits 99 right here. 57 people. So 365 minus 57 is still well over 300. There were still 300 spots, but the probability 2 people have the same birthday, 99%. Kind of crazy. Now, this number starts to get so high, like it gets to 99.999 at 90, when there's 90 people in a room, that when there's 91, that number is so close to 100, the computer just rounds it up. So from 91 to 365, basically guaranteed that 2 people share the same birthday. I hope I explained this well, and I hope you guys enjoyed watching this. I don't know if I'll do more videos like this, but it was fun. So, until next time.